Hello everyone, welcome to Chemazon-Complete Chemistry. So in our today's video, we are going to see some more formula and units. This is the second part of formulas and units. I have already made one video on the same topic of formula and units. In that we had discussed some formulas and units. This is the second part. So if you have not watched the first part, I will provide the link in the description. You can watch that as well. Okay, so in this video we are going to discuss the formula and units of electric charge, electric current, potential difference, resistance, conductance, resistivity, conductivity, kinetic energy and potential energy. So let us first see what is an electric charge. So electric charge is basically we talk in terms of particles, that is subatomic particles. Which are the subatomic particles? Okay, the ones that are present in the nucleus are proton. We know proton is what? We say positively charged. So what is this positive? It is the unit charge of that particle. Okay, so proton is positively charged. We say electron is what? Electron is negatively charged. So we say that electron has unit negative charge. And what is the charge of a neutron? What is charge of a neutron? Neutron is neutral, or we say zero charge. Okay, which are present in the nucleus? Proton and neutron. Electron is present outside the nucleus in the orbital space. So what is the unit of electric charge? If we talk about the unit of electric charges, we call it as coulomb. C-O-U-L-O-M-B. It is called coulomb and it is denoted by C, capital C. And how did we come to know these positive and negative charges? That we will see in the structure of atom via cathode ray experiments. They come to know this these charges. Okay, in the cathode ray tube experiment, let us say there was a stream of electrons. Okay, electrons, we know they are negatively charged. So what was seen, that suppose this is the positive plate, these are charged plates. Okay, and this stream containing electrons was deflected towards the positive plate like this, which means we know that opposite charges attract and same charges repel. So electron is attracted to positively charged plate. So we come to know that the charge of an electron is negative. Similarly, for proton, it deflected towards the negatively charged plate. So we came to know that the proton is positively charged. For neutron, there is no deflection like this. So it means neutron is chargeless. So unit of electric charge is coulomb. It is represented by capital C. Now let us see next one. What is electric current? Electric current is nothing but it is basically the flow of electrons, linear flow of electrons in a conductor. Okay, it is a flow of electrons in a conductor. Okay, that is another definition of electric current. We say that the total charge flowing through a conductor in unit time. Through a conductor in unit time. Unit time means 1 second or 1 minute. Okay, unit means 1. Unit time. So what is the formula for electric current? The formula for electric current is, first of all, what is the symbol for electric current? It is denoted by capital I, or sometimes it is denoted by small I. It is equal to total charge flowing through the conductor in unit time. Okay, so what will be the unit of current? Electric charge unit we saw just now, it is coulomb, and time, let's say it is second. So what is the unit of electric current? We can say unit is coulomb per second. We can write like this, coulomb per second, or sometimes it is written as coulomb second raised to -1, and this is also called as ampere. Okay, this is also called as ampere. Why? Because this was discovered by a scientist called as Andre Ampere. Okay, so that is why we sometimes write ampere, that is capital A. So all these are units of electric current. Okay, so now let us see what is potential difference. Now how do we understand potential difference? In as a theoretical concept, we can say that suppose we say in some tank there is, let's say, water, okay, and there is another some container or bucket or something. So we know that always water will flow from this tank to this bucket only if it is present at the lower height or lower level. So we say that just like water flows from higher concentration to lower concentration. Okay, water here it is flowing from higher concentration, that is from water tank to the bucket. Okay, bucket does not have any water, that is lower concentration. So water flows from higher concentration to lower concentration. Similarly, there has to be some difference of potential. Okay, so that this difference of potential is nothing but called as potential difference. So there should be some this difference of potential so that there can be flow of charge or electric current. Okay, because of this difference of potential there is flow of charge, or we can say electric current. Okay, this was the theoretical concept. If I want to tell about the definition, what is the definition of potential difference? We say that it is the work done in moving a unit positive charge across the circuit. Work done in moving a unit positive charge once across the circuit. Okay, so what is the formula for potential difference? It is denoted by capital V. It will be V is equal to work done means W upon charge. So work done in moving a unit positive charge. That is why V is equal to W upon Q. So what is the unit of potential difference? It is joule per unit of charge is coulomb. So we say joule per coulomb. Okay, so this is going to be helpful where it is going to be helpful to us in electrochemistry. Okay, that is why this is important in chemistry point of view as well. Electrochemistry, when we talk about cell potential. Okay, cell potential, what is the unit of cell potential? It is the same unit, joule per coulomb. It is also another unit is volts. Okay, volts, or we write capital V. Okay, so generally in electrochemistry we use the unit of volt, but we must know that volt is nothing but same as joule per coulomb, so that when we apply Nernst equation we can cancel the units. Okay, so that is the reason this is very important formula of potential difference that we must know. Okay, so the unit is joule per coulomb or volts. It is denoted by, unit is written as capital V. Okay, so now let us see what is resistance. So what is resistance? Resistance is the opposition to the flow of current. Opposition to the flow of current. So what is the meaning of opposition to the flow of current? We say that resistance is inversely proportional to the current, or we can say current is inversely proportional to resistance. More is the resistance or opposition to the flow of current, less will be the electric current or electric charge flowing through the conductor. So since the resistance is inversely proportional to current, okay, resistance is inversely proportional to current. So what is the unit of resistance? Unit of resistance is what? Unit of resistance is, it is called as ohm, and it is denoted by like this. This is the symbol of ohm. Okay, so the unit of resistance is ohm, symbol is like this. Okay, now let us see what is conductance. Conductance means ability to conduct. Okay, ability to conduct electricity. Okay, ability to conduct electricity. So conductance, it is denoted by capital C, or sometimes it is denoted by capital G. Different books give different notations. Okay, it is inversely proportional to resistance. Resistance is a opposition to the flow of current. So conductance will be opposite of that or inversely proportional to that. Okay, so what will be the unit of conductance? Unit of conductance is 1 upon ohm, 1 upon R. R means unit of resistance is ohm. So it is sometimes written as ohm raised to minus 1. Okay, this is called as see this is written as OHM. Okay, so the older unit is ohm inverse. Sometimes in older books you will see people previously used to call it as MHO, mo. Okay, it is inverse, so you interchange these letters. Okay, so in older times it was called as MHO as well. Okay, and in chemistry if we see how this is called as Siemens. Okay, this is called Siemens or capital S. It is denoted by capital S. So this is one of the very important unit for both physics as well as chemistry. In electrochemistry we will be using many times, that is this term called as conductance. Okay, so now next is called as resistance. Now what is resistance? Resistance, resistivity. Resistivity, what is resistivity? It does not have as such any definition, but resistivity, it is fixed for a particular conductor. Okay, so for one type of conductor you will have one fixed resistivity. So we will see the definition of resistivity. Okay, resistivity, if we see, it is directly proportional to the length of the cross section. Cross section means the wire. Okay, length of the wire, this is, let's say, L, and inversely proportional to the area of cross section. Okay, area of cross section, which means if there is more area, then more current can flow. If more current can flow, then resistivity will be less. Okay, and then if the length is more, then also then also the length, if the length is more, then what will happen? Okay, if the length is more and area is less, okay, if the length is more and area is less, then resistance will be higher. R here is what? It is resistance. I have not till yet come to the resistivity. Now this is directly proportional. When we remove a proportionality sign, what we add? We add a constant, and that constant is called as rho. I can write rho L by A. This rho is what? Rho is nothing but the resistivity. Okay, if I rearrange, I can write rho as R into A by L. R into A by L. So now let us see what will be the units of resistivity. It will be, R is resistance is ohm. Area we write as, let's say, meter square divided by meter. Length is in meter. Okay, so 1 meter gets cancelled. So the unit of resistivity is nothing but ohm meter. Unit of resistivity is ohm meter. Okay, so unit of resistivity is ohm meter. This is important. And now if we talk about conductivity, what is conductivity? Conductivity is inversely proportional to, it is denoted by K, capital K, that is called kappa, or sometimes it is denoted by small k. Okay, it is inversely proportional to the resistivity. Okay, similar to, just like conductance was reciprocal of resistance, similarly conductivity is reciprocal or inverse of resistivity. In this way you can relate and try to remember. So 1 by rho. So what was the formula for rho? We had find out just now. It is Ra by L. So what will be conductivity? Conductivity is inverse of resistivity. So it will be L by Ra. Okay, L by Ra. So this we can write, L is meter, this is meter square, and this is ohm. So meter cancel. So what will be the unit of conductivity? It will be ohm inverse and meter inverse. Okay, I can write this as ohm inverse. We had seen just now in conductance. Ohm inverse is nothing but called as Siemens, or S, capital S, Simon meter inverse. Okay, or sometimes it is called as Simon centimeter inverse if the unit is CGS units. Simon centimeter inverse. Okay, now we can rearrange this formula in terms of electrochemistry. How? That we will see again in electrochemistry, but let us see here also how we can modify. Now 1 by R, okay, L by RA, I can write 1 by R into L by A. This L by A is called as cell constant. Okay, we will see in electrochemistry as well what is the meaning of cell constant. And 1 by R is called as conductance. So sometimes it is written as conductance into cell constant we denote by C or some B, or sometimes it is written as X. Okay, so B into C. This is another formula of conductivity. Okay, so the main unit here is Simon meter inverse. Simon meter inverse, or in CGS unit it will be Simon centimeter inverse. So this was another very important unit, that is conductivity. And now let us see kinetic energy and potential energy. So kinetic energy for any body, it is given by, there is a formula that we can use. It is half into mv square. What is Ke? Ke is the kinetic energy. Okay, m is the mass of the body, v is the velocity. So kinetic energy is the energy, it is mostly associated with moving particles. Okay, so all the particles that are moving, they will mostly have kinetic energy. Okay, so now if we talk about the units, half is constant, so there will be no units. Mass of the body, let's say it is kg. Okay, and unit of velocity we had seen in the last video of formula and units. What is the unit of velocity? It is meter per second raised to 2. So this will be kg meter raised to 2 and second raised to 2. So we can write the unit of kinetic energy will be kg meter square second raised to minus 2. So we had seen this was the same unit for work. Why? Because work is nothing but it is the form of energy. Here we are talking about kinetic energy. So now if I move on for the next unit, that is potential energy. Will potential energy also have the same unit? Yes, because it is also energy. So it will have the same units as that of kinetic energy and work, because all the three are nothing but they are forms of energy. Okay, so now let us see for this potential energy. Potential energy, what is the formula? Potential energy formula is m into g into h. What is m? M is the mass of the body. G is the acceleration due to gravity. Okay, acceleration due to gravity. Okay, and h is the height of the body from the ground. So now if I want to find out the units of this, how will I find out? Mass is, unit of mass is kg. G is acceleration. What was the unit of acceleration? Meter per second square. How did we get this? Acceleration is mass into, acceleration is what? Acceleration is velocity upon time. What is the unit of velocity? Meter per second into 1 by t. 1 by t means 1 by second. So this is how we get the unit of acceleration is meter per second square into height, that is distance, again will be meter. So here also you can see it is kg meter square second raised to minus 2. Now kinetic energy is mostly related to stationary objects. Okay, stationary objects will have potential energy. Okay, not kinetic, sorry, potential energy. Okay, so the potential energy is mostly related to stationary objects. So here also we can see the unit is same as that of energy. Okay, so I hope you have understood all the units, and with this beautiful note I will end this video. You keep trying whatever exam preparation you are doing, and you will fail sometimes, you will fail once, you will fail twice, but eventually you keep doing your hard work, and consistency is very important. Whatever you do, you study, consistency is very important. What is the meaning of consistency? Let's say suppose today if you study for 3 hours or 4 hours, let's say whichever exam you are preparing, then every day you have to follow that. Every day you have to study 4 hours, no matter what happens every day you have to study for 4 hours means you have to study for 4 hours. Okay, so consistency is very important, and you be positive and keep working hard. Sometimes you will get failure, but I'm very sure one day you will definitely succeed and everything is possible. So thank you so much.